Hello, everyone. In this particular session, we will be covering OS security and operating system. I believe everyone knows that it's a software program that manages both the hardware and the software resources which are available on our computer system, and it allows like a lot of functions, which is memory management, processor management, file management, input output device management, like even providing security. The most popular operating system is Windows, Mac OS, and there is distribution of Linux, which we installed on our virtual machine, which is Ubuntu or Linux operating system. So in any operating system, the kernel is the core component which allows you to interface between both the hardware and the applications which are running on a system. These application could be any application, whether it is managing the input output device or it is just accessing some application. So we define a system in operating system in a way that it has layers where the physical hardware is at the bottom and the base operating system above it, which is the kernel, which has all the APIs running on it. And on the highest most level is the applications that are running. So OS, as I said, that it allows you for management of hardware resources, which is including memory, processors, input-output devices, keyboard, mouse, and the applications are some softwares which are running on these operating systems so that you can utilize a number of activities on your OS system, which is a software program which is running. So whenever we design a system, specifically operating system, the first step which plays an important role is planning. Careful planning will always ensure you that the system can be made secure, and it compiles with any necessary policies which would help you in the designment of a system, of a particular system. Why planning is important? Because it helps you to make the better utilization of the resources as well as providing checks and controls in the system. So just like if you plan your day ahead in time, you are much more organized and you know how you would be performing throughout the day. So that's why planning is always very important, whether it is OS system or whether it is we as an individual planning our day. It helps us to install and manage the system overall, organize it in such a way that we can provide security checks, like what kind of controls and mechanisms could be given to some individuals, and or some applications should be run by certain people, some applications should not be given the authorization, and other things. So the main aim of planning this OS system security is to maximize security with minimize of the cost, and that helps us in the overall making the system more hardened if we plan the system correctly. So this allows us to have better better system at the end. So this particular figure was taken from Pearson, but what exactly the planning process should be whenever we are developing our OS system. So the planning system should answer all of these questions in order for us to have a better system, which is the type of information which would be stored in the system, which would be the applications, what would be the services which would be running, who would be the users, what would the privileges be given to these users, how would the users be authenticated, whether it is password, whether it is fingerprint, whether it is biometrics, how access to the information for storing the information would be managed. Then questions like what access the system has to provide information stored on the host, such as files, databases, how is it managed, who will administer the overall system, whether it would be root or whether it would be super user, whether it can be given local or remote access, and any other kind of security measure. So planning process always requires you to answer and monitor your system in and giving answers to this. And if you plan your system accordingly, you will have a better and secure system at the end. So as I said, that this planning generally helps you to make the operating system more hardened. And how would you be having a more hardened operating system? Is to secure your base operating system, which in this case, if you are using a Windows machine, that is your base operating system. If you are using a Mac OS machine, your Mac OS is the base operating system. So the basic steps which are generally utilized when you make the system secure at the very initial level is to install the operating system. Once you install the system, you can harden the system by removing if there are unnecessary files, or you can configure some users, groups, and permissions. You can configure even the applications which are running on them, which users can utilize them, and some add-on features also you can install, which are firewalls, antiviruses, that would allow you to make the system more secure. So these are the basic steps. Like initially, whenever we install a new operating system, we add a user firstly. And if we add a user, we also provide what would be the password associated if that particular user is accessing, because we do not want any other person to access your machine. So how do we configure these users, groups, and authentication is by giving some kind of access control to some individuals and some limiting the access control to certain individuals. So how do we do that is by in Windows, we have a different mechanism. In Linux or Unix system, we have a different mechanism. So like, let's suppose some privileges should be given only to the super user. So let's suppose this laptop that I'm using is owned by Texas State. So Texas State knows everything that I'm doing on this particular machine. Me as an individual has limited accessibility. I can initially, when I got this particular laptop, I was not allowed to install any software. And then I was given this privilege by Texas State that yes, I can install. And every time when I install, they ask me to provide my password, because they do not want that somebody else is faking my identity and trying to install any kind of software. So these elevated privileges allows to make the system more secure in more organized manner, in such a way that if a third person comes in and tries to access my machine, would not be able to access the softwares, the application that I have, the files and databases that I have on my machine. So that's the reason configuring these users groups allows to manage the system more secure. And I'll give you some example of what exactly is a user group. But I think by this particular notion, you understand that once we install a system where we should plan out certain rights given to these operating system services that we are doing. So how do we do this kind of security check on a Linux system? Is doing certain commands. So let me open my virtual machine once again. So I'll come back over here. 1 second. And here is my machine. So let me also open. I have all these commands that I have posted, but I will still open it 1 second. On your canvas, you would see certain commands that I had posted last time. Basic Linux command that you can use for you to understand what these commands are saying. So type down all these commands just to understand. Also, for this week also, I had posted certain commands, access control, that I would be going through. And let's first understand the commands. Okay, so let me first open the VirtualBox once again. Okay, so ls command, the very first command is a list command that lists down directory content. So on my PC right now, all the directories and files that I have is desktop, downloads, music, public. These are directories which are available, and there's also a text file. If you see that all the directories are blue in color and a text file, which is hina.txt, is in white in color. If I write ls -a, it will give down all even the hidden files that are available on my machine. So there is this command that you can use. Then ls etc helps me to even know the configuration files which are available on the system. This could be the files which are just limited to the system requirements. And if you want to access some this etc in general is helps you to locate like the overall tree configuration. So all the system configuration files can be listed down by writing ls.etc. There is also manual pages if you want to understand, and for that you can just write man and then the command which is used. So I can write man ls, and that would give me what exactly this command is doing. So it tells what these options are saying, -c, -f, and all of these options. So if I want to get out, I can just say escape Control Z, and it lets me come out of the manual command. Cat command is used to concatenate the files. So if I write cat, it would start printing the content of a particular file, whatever file that I have created. So let's suppose if I make a particular file, what I can do is, let's suppose if I say vim and let me name this as computer security.txt. So what I'm doing is I'm creating a txt file, and a text editor is open. I can click I to insert. So let's suppose this is my test, and I'll say escape and escape :WQ, and it will let you come out. So now I can say cat computer security .txt, and it will give the list of the contents which are available. pwd would give me the present working directory. Presently I am under Hina Ubuntu. It tells me that. ps tells me what are the current processes which are running with the PID, with the time, and what exactly is that process which is running. Process ID tells me the exact process number associated with that particular service which is running. mkdir helps me to create a directory if I want to create a directory. So if I say make directory Hina, so it will create the directory. cp is used for copying the contents from one place to another if I want to copy. So you can even use cp command. Change directories if I want to change. So if I say cd Hina, now I'm under the directory of Hina. Now here, right now I'm under home, Hina Ubuntu Hina. So here where I am presently. Who am I is also one more command which tells me that who the user is, which is accessing this. Now, if I want to go back to the previous, I can just say cd ... and it will come back to the previous folder. And now if I say pwd, it will give me, now I am under home, Hina Ubuntu. So these are some basic commands that you can utilize. Now, the next step that we would be doing is to understand some access rights or access controls whenever we are running any service or any file directory on our system, what exactly these access right is. So let's suppose ls command, if you recall, ls command was utilized in order for us to list down the contents of a particular file. If I say ls-l, this particular command is used to list the contents of directory and display detailed information for each file in the directory. And -l stands for long format. So if you will see right now, I have nearly 44 contents under this directory, which I am presently over here. D, the very first command, like the very first thing over here, dash specifies that it is just a regular file, which in this case is computersecurity.txt. If it is D, the first letter is D, it tells you that it's a directory. So desktop is a directory, which is a folder. Documents is a folder. Downloads is another folder. Hina is another folder. Then the next three things, which is R, W dash, that basically comprises read, write, dash. The third option is execute. So generally, these privileges are given in the form of our the access right, which are given to a particular user or to a particular group versus or to a particular like other. So the first column, the very first column, it indicates the type which is given. So let's suppose the RWX, and this was listed down even in the canvas. Let me open the canvas. So here, if you will see, the first one is the owner, next is the group, and the third one is the user, which is available on this machine. So user is the owner of the file or the directory. The owner has the most permission, and it can perform read, write, or execute. So here in this case, the user, and let me go back over here. The user is Hina Ubuntu, which is the owner of the file I had created. So I'm the particular user. The group, which is the next three parts, is basically the collection of users that have common access permission to the files and the directory. So let's suppose Texas State owns this particular laptop. So that would be considered as a group. And there is a collection of users under this. Hina is one of the users. Then, for instance, XYZ is another user. So this group is a bigger controller which gives access right. So here the second one, which is group, also has the access right as read, write, dash is execute right now, but it is empty. Dash means that the execute is not given. Then R dash dash basically tells that this is for the others, and other refers to all the users who are not the owner or part of the group, but associated with the file or directory. So that's the reason we have generally the first three, these first three gives the user, the next three gives the group, and the next three gives the other. Then one or two basically specifies the number of links. It indicates the number of links associated with this particular file or directory. Then this tells you the owner name, which in this case is Hina Ubuntu. The fourth column basically tells you the group associated with the file or directory, which in this case is once again Hina Ubuntu. Next tells you the size, which is the size of the file in bytes. Generally, if it is a directory or a folder, the bytes associated is 4096. This is typically, if it is a folder or a directory, the bytes associated would be 4096. I created this text file and I had inserted some contents in it, and that's the reason it contains 17 bytes in it. Next gives you the date, and then gives you the time, and then the file, which is file number, file name associated with that particular file. So ls-l gives you the detailed information, which is in long format, tells you what exactly, who owns the file, who is the user of the file, who is the group owner, and other things. So all this information is stored, and we can access this using ls-l. Next, there are some commands that you can utilize. So let me open these commands as well. So I think this was it. Yeah. So let me run these basic commands. Let's create a new file. So I had created this file called Hina. So let me just open cat hina.txt. Right now, it just contains a content called hello in this case. Now let me add a user. So right now I own this machine. Hina Ubuntu is the user, and even the group owner is Hina Ubuntu. Now let's just add a new user. So if for us to add a new user, I will use sudo, then I can user add, and let me just create a test user. So I'm creating a test user in this case. So it is asking me to provide the password. So I'll provide the password. It says that the user test already exists because I had already created. So I can even delete. So I can write user del test, I think. Now, if I do is sudo user add test, a new test user has been created. I can provide password. So I will just say sudo password and test. I will just create the password as test and retype password. I'll just write test and password updated successfully. Now, if I'll say ls dash l once again, it has all this information right now with no modified changes. The only change that we have done is created a new user. Now let's suppose this file which I had created, which was hina.txt. Right now, the user for this hina.txt is Hina Ubuntu. Now I want to give the ownership to someone else, which in this case is the test user. So how do I do that? I can use this command called sudo chown change ownership. Ch, which is change, ownership means to change the own means to change the ownership. Then provide the name of this user, which in this case is test. And what is the file name that I want to give access, which is hina.txt. So now that should be modified. So which means that now hina.txt should be owned by test user. So now if I say ls-l, it will tell me that see hina.txt is now owned by the user, which is test in this case. It is no longer Hina Ubuntu, but it is test. If I want to even change the group, here I change the ownership. If I want to change the group, I can even provide the change of group, which is chgrp to change the group, which once again I will say it as test and hina.txt. Once again, if I say ls-l, you will see now both the user, the ownership and the group has been changed, which is test. If I want to change the contents of a particular file, so I'll just say this particular file, which is test file, and I will just say the password associated with it. So test, I'm going to the super user, which, sorry, the user test. So the password was test in this case. And I want to change the access right to this hina.txt. So hina.txt, who is right, test is the owner. So that's the reason I changed my super user right now to test. And now chmod would help you to change the executable rights given to this user, which is test, or to this particular file. So RWX, as I said, RWX is read, write, and execute. So right now for this test user, the access right is given as RW and dash, which means there is no execute option. If I want to change this, I will say chmod plus X, and it will change the access. It is giving plus X means add execute rights to this particular file, which is hina.txt. And now if I'll say ls-l, you will now see the user, which is rwx, also like now the previous time it was rwn dash, now it contains rwx, which is execute write is given. Now if I want to exit to my previous one, I'll just say exit. So now I'm back to my main machine. I had moved to the test user, but now I'm back to Hina Ubuntu. Now, if I want to, since the access right is given to test, let's try to change the access right now from the base operating system, which is Hina Ubuntu. So if you will see, presently I'm under home, Hina Ubuntu. Now, if I say ls-l, you will see that test is the user, test is the owner for this file, which is hina.txt. Now, being on Hina Ubuntu machine, I'll change the access right to this particular file, which is hina.txt. So let me just use chmod. And now I want to change the access right, and I will say -x. I want to remove the execution privilege given to this particular file, which is once again hina.txt. If I'll enter, it says changing permission of hina.txt operation not permitted. Why? Because now I'm in Hina Ubuntu. I'm no longer in test. If I want to change the accessibility for that particular file, once again, I have to make, instead of making test as the user owner for this particular file, I have to make it Hina Ubuntu as the owner of the file. So this way, you can provide accessibility for a certain file. So once again, let me go to come back to super user test, and here I'll provide my password, and I will say change own, and I want to make Hina Ubuntu and hina.txt. I will say sudo chown hina.txt, and the password is. So it says that sudo test is not in the main file, and it is not allowing me to change the accessibility. So for me to give rights to this, I have to be the super user, and then I have to change the ownership. So here in this case, I'll go back once again. And what I'll do is sudo chown Hina Ubuntu, and then hina.txt. So now if I'll say ls-l, it will now make it, now the owner is Hina Ubuntu. Once again, I can change the group once again, and this time I'll say change this to this, and ls dash. It is now both username, and now I can change the accessibility. So now I want to remove change the accessibility to this. So now I can change, and ls-l. Now you will see execute write has been removed to this particular file. So this is how you can provide some accessibilities to your Linux operating system. And that's what I gave you some examples of users, groups, and permission. There is also one more command called chroot jail. You can read online about this chroot jail, but this is similar to like a jail concept, that it's to isolate an application and its dependencies within jail. And the jail appears to be the root file system, and while the rest of the file system becomes inaccessible. So what exactly the chroot jail does, it restricts the application access to the file system, and it can be used to limit its capability and to prevent any kind of malicious behavior. So you can read online and understand what exactly the chroot jail is generally doing. Okay, next, how do we provide Windows security? So far, it was just giving access right to on the Linux system. The same thing can be done on Windows machine. And the first thing is that you can regularly update your Windows machine whenever there is a sub update provide. Similarly, on Linux, you can just say sudo apt-get update. That will update any patches which are like these are the security patches which are created. Besides this, there are some models, and that's what we will be covering next week, like Biba model and other models which are utilized to give some kind of access right to these to machines. So besides this, you can even have the configuration settings which are available on this registry. And this is just a, like if you will search on internet, not internet, on your machine, if you will see, you will have like the registry for each of the files which are available on your machine. So this is current user, the environment is under C users. All this information comes over here if there are any printers, if there are any network. So these registers helps you for any kind of service configuration on your Windows software if you have a Windows machine. Okay. Next is what exactly is virtualization. So we discussed about the security, which is on Linux, on Windows. What about this virtual machine? Why did we install these virtual machine, and what is this concept of virtualization? So virtualization is a concept which helps you to create a virtual version of something, such as an operating system. It could be a server, it could be a storage device, it could be network resource. It allows multiple systems to run on a single physical device and isolating the applications and data from each other. So traditional system, which is basic before you did not install your virtual machine, it was just a traditional architecture. On top of it was the operating system, which is the base operating system, which could be your Windows or Mac OS. And on top of it was the application. So we have our kernel, we have our hardware and all these applications. This was the basic concept which was utilized in any computer system. With the advent of virtualization, what exactly happens is that you have your hardware, you have a virtualization layer now. Instead of your operating system, you have a virtualization layer. And on top of the virtualization layer, you can have multiple OS, which could be Windows, which could be some other Linux machine, or it could be Ubuntu or anything else, whatever you want to install. So the way this can be enabled in a system is using some virtual environment. And virtual machine is one kind of software-based virtual environment that helps you to like have this another operating system machine on your own system. So you still have your hardware, but instead of your base operating system, you have your virtualization layer, and one block is reserved for one operating system and another block is reserved for another operating system. The principal function that allows you to manage this is using this concept of hypervisor. And it is a type of tool that creates and manages these virtual machines. And what exactly is that? So it's a software that sits between the hardware and your virtual machine. So it's a tool that creates and manages a virtual machine. It provides a kind of abstraction layer between the physical hardware and your virtual machine, and allowing the virtual machine to share same physical resources and while maintaining isolation. So all of them would be using same kind of resources, but there is an isolation. So whatever we are doing on our Ubuntu, virtual machine Ubuntu, is isolated from your base operating system, which is Windows, if you're using Windows in this case, if you are using versus if it is a Mac OS. So a hypervisor is responsible for allocating and managing those physical resources. It's a concept or a software that creates and manages virtual machine. So that allows you to have a virtualized system, and that virtualized system is properly allocating the hardware resources to your virtual guest OS, which in this case is Ubuntu. What kind of CPU, utilization number of processors, number of disk, and other things. So when you were installing your virtual machine, those things you were providing that I want to allocate 2 processors while this operating system is running. So it will create a virtual disk where all of these processors would be running and other kind of things. So you created a virtualized system, which is an Ubuntu machine, which is separate than your main OS, which could be Windows or Mac OS. So there are 2 kinds of hypervisor. I'll go back to container, what exactly is container, but there are 2 kinds of hypervisor. One was the traditional hypervisor, which runs directly on the host machine physical hardware, and it provides like it's your hardware, then you have hypervisor, and then you have your guest OS, which is one OS, then it would have some libraries. And so when you start your laptop, you would be asking whether you want to go to Windows or whether you want to go to Ubuntu. And based on it, it will just go to that particular system. So this results in better performance and security as compared to type 2. So what we did is Hyper 2 hypervisor, which is a hosted hypervisor. So where you have your hardware and on it you have your host OS. So whatever was your host OS, mine is Windows, and on top of it I have this hypervisor where I installed an Ubuntu. So the base operating system is Windows, and on top of it was this hypervisor, which helps you to communicate between creating virtual machine, and on this virtual machine we have this Ubuntu. So Hyper 2 hypervisors, type 2 hypervisors are typically used for testing and development purpose. For our case, it is mostly used for security. If you are managing or changing access right and other things, you can manage on your Ubuntu, which is a separate guest OS. So examples of them include virtual machine. So virtual machine was the type 2 hypervisor that we have utilized. We have not done type 1, which is the native one. And what it means in type 2 is that the virtual machine share the resources of the host operating system, making it less efficient than the type 1 hypervisor. That's one of the things. Now, the next thing is containers. So what exactly is container? And this is a new technique, new advanced utilization, which is a recent approach to virtualization, is your container. Containers and virtual machines are both technologies for isolating applications and its dependencies to run on a shared host, whatever host you have, but they differ in certain ways. So one is resource usages, like the usage of resources. Containers are more lightweight and efficient as they share the so there is an infrastructure layer. On top of it is a host operating system, and on top of it is a Docker. And Docker is just like hypervisor. This Docker allows you to pull these applications that you want to run. So containers are much more lightweight in comparison. Then besides this, virtual machines provide complete isolation, but containers do not do that. Like containers are, they share the host operating system, but provide isolated namespace and resource controls. Besides this, containers are designed to be portable and can be easily moved between hosts as long as the host operating system is compatible. Even containers can be deployed and scaled easily as they start and stop faster than virtual machine and consume less resources. So that's exactly is our this new concept, which is container. Now, if you have to differentiate between type 1, type 2, and this container, as I said, most of the companies now use container concept. Initially, I was also planning for this particular class, but last time when I had when I created this course module, there were very less students which were comfortable, and I thought that just moving into virtual machine would be much applicable. So once again, if we have to differentiate between the three of us, container is a standalone executable package that includes everything to run a piece of software. So it's like not creating an another host operating system. It's kind of a package that includes everything, whether it is code, libraries, environment variables, config files, and it's a package, and it allows you to pull that particular package on your machine, run them on your machine. Type 1 and type 2. Type 2 are less efficient than type 1, but it allows you to have multiple virtual machines on your base operating system. So there are some security concerns associated with these virtualized system which is having this accessibility which is given to your guest OS. Make sure that the program executing within a guest OS may only access and use the resources associated to it. It shouldn't be accessing some other base operating system accessibility. So the example was when I created this test user, and test user tried to give the access right, which was execute right to this file. So make sure that you ensure that the accessibility cannot be granted. Then guest OS monitoring by the hypervisor, which has privileged accesses to the programs and all the data in guest. So these are some things that you have to keep in mind so that there is less vulnerability on these virtualized environment that you are using. So based on this, the next important concept that we would be discussing is access control. So access control, it's an act of achieving confidentiality and integrity on your operating system. The example on your Ubuntu machine, we understood that access right could be given to some users, some groups. So those are the subjects. What kind of access right would be given, which was read, write, execute? That was who was accessing what, and what exactly we would be giving access right to, whether it is files, programs, sockets, hardware. So access control is the basic concept which is utilized in understanding who can access what, who are the users, who would be the group owner, and other kinds of things, like having a layer by layer clarification on who should be accessing what access right would be given, which is read, write, and execute, and finally, what are the files that would be given these access rights. And that would lead us to the models that have been created under these access control mechanism. So if we will see that any operating system, we have the hardware, then we have the OS, then we have middleware, which are the databases which are running, and what are the applications which are running on the topmost level. So moving from any hardware to the application is always like, it's easy to move, but the accessibility are generally given on the application level, so that this application would be given access right to these individuals. If there are more subjects, like, then security plays an important role, because if there are multiple users accessing the same limited resource, the vulnerability associated with that machine would be high. And interrelationship also plays an important role, and it becomes difficult when there are multiple users at the same level. So let's suppose this laptop can be accessed by me and some other faculty, and both are given the same access right. So interrelationship plays an important role. What accessibility I should be given versus what accessibility the other faculty member would be doing. So both are at the same level. So Texas State is the higher level, then two faculties are at the second layer, and the third layer would be the students who are given. So how does the accessibility between these user to user plays? Complexity increases when we move from hardware to the application level, and reliability decreases, more prone to loopholes. So that's what this access control plays an important role at the application level. So there are some policies and some mechanisms just at the hardware level. So the hardware layer, which is the bottom layer, how accessibility can be given at the hardware layer. Some policies are that you should protect your OS from some vulnerable application, must protect application from individual to individual, must prevent one application from hogging from one system to another system. These are some policies that we should be having in on an hardware access control. There are some mechanisms that you can do at an hardware level. One is paging unit, which is isolating one application address space from another application space. So paging unit is a basic concept in operating system. This can be utilized. Privilege ring is another kind of concept, which is that all these Intel x86 rings are generally coming in like 1, 2, 3 rings. So OS runs in ring 0 and application runs in ring 3. So providing these privilege rings would also allow you to achieve the policies of protecting your system. Finally, interrupts, which is scheduler. If two applications wants to access the machine at the same time, how you can provide interrupt control or scheduling, round robin or other kind of things. This can also be achieved on this hardware level. So with this, I would end the lecture that, and we will be covering the access control in the next class, that how what are the different models which are utilized at the OS level in providing these access control. So at the OS level, what we can do is that some users could be given some access right, some users could be given some other kinds of access right. How do you differentiate? How do user to user communication, like the access right between users, how would that play an important role? So access control mechanism is one way of achieving the access control, and there were two models, and we would be understanding these BIBA model, which is applicable to give access rights at the OS level to these files and directories that would allow better hardening of our operating system. So with this, I'll end the class, and then next week we'll cover the access control rights. Thank you, everyone.